First, let us see what we know so far. We know the population. We can generate a sample from the population. We introduced two methods to generate a sample: random sampling, representative sampling. We can analyze the sample and find some patterns characteristics in this sample. We want to see whether those findings or characteristics that we found in this sample can be used for the population, or whether those findings is coming from the population. So we generate some statements for the findings and generate some tests for the findings. To do that, we set hypotheses. We have two hypotheses: null hypothesis, alternative hypothesis. They are opposite with each other. Null hypothesis is always conservative. It states there's no effect, there's no difference, there's no findings. We introduce a p-value. P-value tells us how likely we see the same effect or patterns can be happened in the population. We also know the significance level. We needed to set the significance level before we're doing the hypothesis testing. We introduced two types of the error: type 1 error, type 2 error. We have discussed the mean test, compare the sample mean and the population mean. It's also called the one sample mean t-test. Here we use X bar represents the sample mean, mu represents the population mean. We have two ways to state the alternative hypothesis: two-tailed test and one-tailed test. For the two-tailed test, so we just say there's a difference in the population mean and the sample mean. So for the null hypothesis, it's the same in the two-tailed test and the one-tailed test. Only in the alternative hypothesis they are different. So for the one-tailed test, so if we assume the sample mean is larger than the population mean, so to generate the alternative hypothesis, we will say the sample mean is larger than the population. And if we assume the sample mean is less than the population mean, so when we generate the alternative hypothesis, we will state the sample mean is less than the population mean. We generate the t-score for the sample mean. So the t-score can be calculated based on the difference between the sample mean and the population mean divided by the sample estimate of standard error. The t-score is related to the t-distribution. After we have the t-score, we can take a look at how many of observations lie below the t-score in the t-distribution and how many observations lie above the t-score. Based on the percentage of observation lie below or above, we can get a population that such effect happens on the population. So based on the percentage of the observations lie below and above, so we can get the probability that such effect happens on the population. For if we have the sample size n, so we can get the t-score associated with the t-distribution with a n-1 degree of freedom. Here, we assume the sample mean is larger than the population mean, so we can first generate the hypothesis. Non-hypothesis will be there's no difference between the sample mean and the population mean. Alternative hypothesis is, say, the sample mean is larger than the population mean. First, we set the significance level equal to 0.05. So we want to have 95% confidence level in your results. So we want to find that given a certain population mean, what's the possibility to get such large sample mean? To do this, so we take a look at the t-score as we discussed before. And if the t-score is pretty large compared with other value in the t-distribution, so we can conclude the sample mean is very large than the population mean. And this is unlikely to happen due to the sampling, representative sampling or random sampling. So as I mentioned, the first thing we need to do is calculate the t-score. Then take a look at where the t-score lies in the distribution. If the t-score is large, and we can see how many observations below the t-score and how many observations lies above the t-score. And here we set the significance level equal to 0.05. We have the 95% confidence level. So based on this confidence level, we check the we get the threshold. It's a T95. Which means this threshold, which means we have 95% of observations located below this value, and we have 5% observations located above this value. And if the t-score we calculated here is below the threshold, we will not reject the null hypothesis, and we say there's no difference in the mean. Otherwise, if the t-score we calculated here is larger than the threshold, so we reject the null hypothesis, and it supports the alternative hypothesis, which means the sample mean is larger than the population mean. So here we call this area is rejection region. Let's take a look at another one. Here we assume the sample mean is less than the population mean. So we also set the significance level equal to 0.05. So we want to have 95% confidence in our results. So we want to find, given a certain population mean, what's the probability to get such small sample mean. So we first calculate the t-score and find the location of the t-score in the t-distribution. And based on the confidence level, we try to find the threshold. And here, this one is because we want to see to check whether the sample mean is less than the population mean. So it will locate it on the left tail. So here we can see based on the confidence level, we find the threshold is T5, and which means we have 5% T value is lower than the T5, and we have 95% of the values is above the T5. And if t-score we calculated here is above the T5, so we will not reject the null hypothesis, which means there's no difference in the population mean and the sample mean. And if the t-score we calculated is below the threshold, it's located in the rejection region. Okay, so we will reject the null hypothesis and say the sample mean is small or less than the population mean. Here, let's take a look at the two-tailed test. Here, so we don't know whether the sample mean is larger than the population mean or smaller than the population mean. We want to check the sample mean is different from the population mean. We set the significance level equal to the 0.5, which means we want to get the 95% confidence in our results. And if the t-score is extremely high or extremely low, and only happens in 5% case, so we reject the null hypothesis. Otherwise, we do not reject the hypothesis, which means the t-value can be very large or can be very small. So the threshold here we set is 5%. But since here we have two kind of extreme value, so we need to create two thresholds. We need to divide the 5%, the significance level, into two cases. One is the 2.5, another one is 97.5. So we find the t-value with the 2.5 percentile of the t-distribution, and the t-value for the 97.5 percentile of the t-distribution. So then we calculate the t-score. If the t-score located during this range, and we not reject the null hypothesis, which means because the t-score not located in this extreme value. But if the t-score located here, like below the t-value, the 2.5 percentile of the t-distribution, and so we will reject the null hypothesis. If the t-score located above the t-value, the threshold, so we will reject the null hypothesis as well. So here we have two rejection regions. One is for this observations located in this rejection area is 2.5%. And for this one, it's also 2.5%.